Question 9 is a little bit similar to question 7. What we've got is we've got these three forces acting on a particle. But for the first section, the particle is in equilibrium. So that means that either it's not moving or it's moving at a constant velocity. Either way, there's no acceleration. That means that because the particle is in equilibrium, there is no resultant force. So if I add up force 1, force 2 and force 3, I will get an answer of 0. So let's add them together. I'm going to do it in vector form because I like that more than having lots of i's and j's floating around, but you could just leave the i's and j's in if you prefer. So I've got 3a and 4b for that first one. Add on 5b and 2a. Add on minus 15, minus 18, and I get an answer of 0 because we said that there's no resultant force, so all those forces add to 0. Let's look at this top line then. We've got 3a plus 5b minus 15 equals 0. I'm just going to take that minus 15 to the other side and write it as 3a plus 5b equals 15. Then for this bottom line, I'm going to do the same thing. If I take the 18 to the other side, I get 4b plus 2a equals 18. So what I've got here is a set of simultaneous equations. I'm going to solve them on my calculator. So if I go to equations, and I've got simultaneous equations with two unknowns. So firstly, I've got 3x but 3a plus 5 is equal to 15. Next one is 4, oh, careful here actually, that's 2a and 4b, and that is equal to 18. So I know that a is therefore equal to minus 15 and b is equal to 12. You could obviously do it the long way by hand, but it's much quicker to do it on your calculator. So I found my values for a and values for b. Now in part B, this final force here is removed. And now we need to work out the magnitude and direction of the acceleration, because there will be an acceleration now. Well, because there's an acceleration, I know that the resultant force is equal to the mass times the acceleration. That's Newton's law. The resultant force is just the sum of those two forces that are acting. Remember, this one's been taken away, so that's not involved anymore. So if I do 3a, that's 3 times minus 15, and 4b, 4 times 12, and I add to the other force that is acting, which is 5b at the top, so 5 times 12, 2a at the bottom, 2 times minus 15, then my answer is equal to the mass, which we know from the question is 2 kilograms, times by the acceleration, which is what we're trying to find out. So I'm going to, for now, use x and y to represent the acceleration. Well, let's multiply out here. So 3 times minus 15. Let's go back to normal mode. 3 times minus 15 plus 5 lots of 12. Probably didn't need to do it on a calculator. 15. 4 times 12, and then adding on 2 times minus 15, which is going to be 18, and that is equal to 2 times the acceleration. Well, hopefully we can see that if we just divide by 2, we will work out what our missing values x and y are. So I can see that x is going to be 7.5 and y is going to be 9. So that means that my acceleration vector is 7.5, 9. Now we're not quite finished because the question wants to know the magnitude and direction of the acceleration. We've just found it as a vector. Now to find the magnitude, we're going to use Pythagoras. So we've got 7.5 in the I direction, so that's 7.5 across here, and 9 in the J direction, so 9 is up there. So the magnitude of this acceleration vector is worked out by using Pythagoras, so the square root of 7.5 squared plus 9 squared. And if we put that into our calculator, 7.5 squared plus 9 squared. And that is 11.7 to the, what we're doing, meters per second squared. Then to work out the direction, what I'm going to do is, I probably want to give the direction as a bearing. So what I really want is this angle here, which I'm going to call alpha. So to find alpha, I'm going to first work out theta and then do 90 take away theta. So I know that theta is equal to inverse tan of 9 over 7.5. Inverse tan of 9 divided by 7.5, which is equal to 50.2. And then to work out alpha, I will just do 90 minus that. And that is 39.8 degrees. So I would say that the magnitude of the acceleration is equal to 11.7 meters per second to the minus 2, and the direction bearing is equal to, well, that's going to be 0, and I'm just going to round it to two significant figures, 40 degrees. So there's my magnitude and there's my direction. Now the next part of the question wants to work out the distance travelled by the particle in the first 3 seconds. Well, to do that, we're just going to use that. So let's just fill in what we know. The acceleration we just worked out is 11.7 meters per second to the minus 2. Then to work out some of the other things, we know that it's starting off from rest, so it's from 0 meters per second because it's in the first 3 seconds of its motion. That means therefore we know the time is going to be 3 seconds, and we want to work out what the distance is, s. So I'm going to use s equals ut plus a half at squared. So I've got s is equal to, well, that's 0 times 3, that just can disappear, a half times 11.7 times by 3 squared. And if you type that into your calculator, you should get the distance is equal to 52.7